Hello students, I am Dr. Nimi Singh. Today I bring you the next learning episode on behalf of the content writers, myself and Miss Silica Banerjee. In this episode, we will discuss about the chemical composition of the glass. Here we will learn about the classification of glass, class and individual characteristics of glass. We would also acquaint ourselves with the collection, preservation and handling of glass at a scene of crime. We will then end up this module with the importance of glass in various cases. Let's have a look at modules which are we going to learn today. Module number 1, that is the introduction and definition of glass. Then comes the chemical composition of glass, classification of glass, class and individual characteristics of glass, the collection, preservation and handling of glass at a scene of crime, the importance of glass in various cases, and in the end the conclusion. Now let us come to the introduction of the glass first. The knowledge about the glass and its composition plays a very important role in the field of forensic science. It makes the examination of the glass that has broken or being used for committing the crime easier for the investigation team. The material of the glass reveals its make and helps reaching the suspect. Silica is the main ingredient which is used in glass along with other minor ingredients like metal oxides and color additives. Now, depending upon the composition of the minor ingredients, there are different types of glasses like lead glass, soda lime glass, aluminosilicate glass, borosilicate glass, etc. Coming to the definition, glass is defined as an inorganic product of fusion that has cooled to a rigid condition without crystallization. Glass is an amorphous, hard, brittle substance which is usually transparent but translucent and also opaque at times. It is formed by the fusion of one or more oxides like silica, boric oxide, phosphoric oxide and some metallic oxides, followed by a rapid cooling of the fused material to prevent crystallization of the components involved. In other words, glass can be considered as a supercooled liquid of extremely high viscosity. Coming to the chemical composition of glass. The following are some ingredients which are used in the manufacture of glass along with some additives required for specific properties. Now, coming to sand or silica. Silica is the main ingredient for glass making with a very high melting point of around 2000 degrees centigrade. This is the major reason why it is possible to make products like halogen lamps from just silica itself. It is mainly obtained from the pure sands of Perengarenga harbour of North Cape. It is washed and sifted to remove shells, stones before mixing. Then comes the sodium carbonate or soda ash that we call. Sodium carbonate is added to make the process of glass manufacturing more efficient as it reduces the melting point of silica to around 1000 degrees centigrade. It was earlier found in the ash of some plants, but is now produced from the table salt itself. But sodium carbonate tends to make the finished glass water soluble, which is not desirable in glass making. Its main source is from USA. Then comes lime or calcium oxide. Calcium oxide is extracted from limestone. It is added to counter the effect of sodium carbonate and to make the glass insoluble in water. Its main source is Vetumum. Coming to metallic oxides, aluminium oxide and magnesium oxide are added to further enhance the properties of the glass. There are other additives also. A number of different other ingredients are added in order to change the properties of the finished glass as per the requirement. Some examples are lead. Lead is added to make crystal glasses. Because of its good reflective properties, the glass thus formed appears to sparkle, which is used for creating decorative patterns on the ordinary glass. Then is boron. The addition of boron changes the thermal and electrical properties of the glass and is thus used to make Pyrex glassware that can withstand extreme temperatures. Lanthanum oxide. With its excellent light reflective properties, it is used to make high quality lenses in glasses. Earlier, thorium oxide was used, but due to its radioactive properties, it is no longer used. Then is the iron. It is used to absorb infrared energy in the heat absorbing filters installed in the movie projectors. Coming to the classification of glass. Depending upon the chemical composition, all commercial glasses are divided into 6 basic categories. The first one is the soda lime glass. It is the most common and cheapest form of glass. It is used for manufacturing window glass, bottles, containers, light bulbs, bangles, ophthalmic lenses, car headlamps, etc. The common oxides found are sodium, calcium, magnesium and aluminium. It is not highly resistant to high temperature and sudden changes in temperature while being resistive to corrosive chemicals is fair. The composition is as follows: silica 60 to 70%, soda 12 to 18%, lime 5 to 10%. Then comes the lead glass. This type of glass has fairly high percentage of lead oxide. It is quite soft and because of its high refractive index, it gives brilliance to the glass. As a result, it is used to make decorative glassware, neon sign tubes, thermometer tubes for the absorption of X-rays and other radiations. Its excellent electrical insulating property makes it favorable for electrical applications also. This glass is more expensive than soda lime. It cannot withstand high temperature and sudden temperature changes as it has got a very low melting point. The composition is as follows: silica 54% to 65%, lead oxide 18% to 38%, soda or potash 13% to 15%. Then comes the borosilicate glass. This type of glass has got substantial amount of boric oxide, which makes it resistant to heat, acid corrosion and alkalis. They are not as easily fabricated as soda lime or lead glass and are hard as they have lower coefficient of expansion and hence can be used at high temperatures. These glasses are used for making laboratory glasswares, domestic ovenware, in industry for gauge glasses, pipelines, photochromic glasses, sealed beam headlights, etc. The composition is as follows: silica 70% to 80%, boric oxide 7% to 13%, alkali 4% to 8%, aluminium oxide 2% to 7%. Now comes aluminosilicate glass. This type of glass has got aluminium oxide added to it. Although it is similar to borosilicate glass, but it is hard to fabricate and has got greater chemical durability. It can also withstand very high temperatures as its melting point is almost 1000 degrees centigrade. It can be used as resistors for electronic circuits. The composition is as follows: silica 67%, aluminium oxide 17%, calcium oxide 8%, magnesium oxide 7%, 96% silica glass. Now, it is a type of borosilicate glass from which all the non-silicate elements have been removed. This glass is resistant to temperatures of up to 900 degree centigrade. Then comes fused silica glass. It is a glass which is made up of pure silicon dioxide in a non-crystalline state. It is very difficult to fabricate and is the most expensive of all types. It can sustain temperatures of up to 1200 degrees centigrades. Coming to the class and individual characteristics of glass. A preliminary examination of the surface of the glass will indicate the source, which is a flat surface, maybe from a winter glass or plate glass, a cylindrical surface from a bottle, a spherical surface from a spectacle glass or headlamp glass. This examination is done considering that the two glasses do not have a common origin. This examination is achieved by considering surface texture, pattern, color, etc. Now, the general condition of the glass should be inspected minutely using a stereo microscope even before cleaning. Moreover, it is desirable to select glass fragments with edges that appear freshly broken. A physical fit between two glass fragments actually is the best method, but due to different types of fractures generated in glass, physical fit is actually very rare. It requires the edges of one fragment to perfectly fit into an edge of another. A complementary lateral fit along the broken edges over a length of 1/4 of an inch or more establishes that the two glass fragments were continuous before breakage. The match is 3D. So, under stereo microscope, the edges of the samples are carefully observed, which will exactly fit into each other. Lateral pressure has to be applied in order to see that the small irregularities intermesh and hold the pieces together so that one can feel the sense of exact fit along the broken edges. For a sheet of glass, and if the pieces of smaller sample have portions of both the surfaces present, then it becomes more useful to measure the thickness using a micrometer screw gauge. The thickness of the glass sheet may vary from one place to the other and may have uniform thickness throughout or may not have a uniform thickness throughout. Thus, it becomes beneficial to study the variations in their thickness before comparing the thickness of the control sample and that of the crime exhibit. Thickness. Now, for measuring the thickness of glass, a micrometer screw gauge is used, which incorporates a calibrated screw mostly used for very precise measurements of components. Curvature. Determination of curvature surface can help distinguish that glass from other types of glass like containers or decorative glasses. A spherometer is used to measure the radius of curvature of the glass fragments having curved surface. The radius of curvature is found using the following formula, that is R is equal to 12 by 6h plus h by 2, where L is the mean distance between the legs of the spherometer and h is the height of the curved surface. If the glass fragments are large, then stereo microscope can be used. Then comes the color. On some very rare occasions when glass fragments associated with the crime are colored, for example, decorative glasses or bottles, then the color would be used for exclusion or identification. Even colorized glasses are usually found to have some perceptible tint. Thus, when the large fragments of glass are available, their color should be compared. Comparing color can distinguish between two or more sources of glass. Sample size may affect apparent color, therefore, side-by-side comparisons should be made of approximately equal and sufficient size. Pieces of at least 5 mm are desirable. The fragments are placed on white background, for example, fine filter paper, and the comparison is made in bright diffused daylight. The examination will be able to distinguish between the true color of the glass and the color of any coating that may be on the surface of the glass. Observing the glass using both fluorescent and incandescent light is useful in distinguishing different colors or tints using a spectrophotometer. But most of the time, it is not possible to compare the color of microscopic glass fragments due to insufficient color density. Now, color additives. Color to the glass can be either done by glass oxidation or by introducing a large variety of additives. It is actually difficult to make a clear glass. Metals and oxides are also used to give color to glass. Glass oxidation is promoted by the addition of carbon, while the degree of oxidation is measured on an arbitrary scale known as carbon number. For example, a clear glass has carbon number 0, a dark green glass has carbon number 28, various additives and colors they give. Iron oxide gives blue color, iron oxide and chromium will give richer green, sulfur, carbon and iron salts will give amber yellow color, manganese will give purple, selenium red or pink, cobalt blue, tin oxide, antimony and arsenic white opaque, copper oxide turquoise and nickel blue. Coming to the fluorescence, although most of the glass samples exhibit little or no fluorescence, some types of glass fluoresce with colors which may be blue, violet, brown, purple or green when examined in ultraviolet light. Hence, in most of the cases, it is very useful in distinguishing between different glasses. This examination is done by observing glass fragments over a non-fluorescent background by illuminating it consecutively by short wavelength, that is 254 nanometer, and a long wavelength, that is 350 nanometer ultraviolet light. While comparing fluorescence, fragments of similar thickness should be used, but before comparison, a thorough washing to remove oil, grease or other possible fluorescent foreign debris on the glass surface is absolutely necessary. Coming to hardness now, since glasses vary appreciably in hardness, this property may also be used for differentiation. The hardness determination is possible on an arbitrary scale and requires internal standards. Thus, two fragments can be compared for hardness by determining their mutual scratching powers. If the hardness difference is small, then it becomes helpful to study the scratches or attempted scratches under a low power binocular microscope. Then comes the property of surface tension. Features on surface can be formed either intentionally or accidentally during manufacture or fabricating processes. These form another basis of comparison to distinguish between different sources of glass. They can serve as identifying features while examining the glass fragments for fracture match if the feature is present on both the fragments. Surface features include coatings, thin films and mirrored backings, etching, texturing, etc. Now, coatings of thin films. Coatings or thin films are usually seen on architectural or automotive glass. These films are actually done to increase the durability of glass and are composed of wide variety of materials in single or multiple layers. They may be amorphous or polycrystalline. The thickness of coating can range from nanometers in thin films to millimeters in mirrored. Coatings can be applied to either one or more surfaces. Since it is not possible to distinguish coatings, so instrumental methods of analysis like X-ray diffraction can also be used for this purpose. Manufacturing features. Now, intentional surface features include etching, texturing, frosting, etc., while accidental surface features are as a result of manufacturing that include rogue pits, polishes, etc. They can be visually compared very easily. Now, additional surface features. This is nothing but distinguishing between glass fragments in terms of scratches, abrasions, etc. on them. These should be examined and characterized carefully using stereo microscope before cleaning. Coming to the collection, preservation and handling of glass at the crime scene. Now, collection and preservation of glass samples. Wrap shoes, clothing or other objects contaminated with glass in paper before submitting to the laboratory for examination. All glasses found at the hit and run scenes should be recovered. The search for glass samples should not be restricted to the point of impact. Headlight glass may be dropped off at some distance away as the car leaves the crime scene. Use different containers to collect glass from different locations. All glass evidences found at the crime scene should be collected because more than one type may be present. In addition, if just a few representative samples are saved, individual pieces that could be physically matched with the glass remaining in the headlight shell of the suspected vehicle may be overlooked. The glass pieces collected from different locations must be packed into different containers. Mark clearly the outside packaging as the location and description of the evidence. Label large glass pieces with orientation marks, for example, up, down, inside, outside when applicable. A rigid container must be used to collect and package a large glass piece. The broken or fractured edges of the glass must be protected from any additional damage or rupture. Depending on the size, glass pieces can be packaged in envelopes, bags or in paper folds. Place the small glass particles onto the adhesive of a post-it note and use a pen to circle around it. Glass pieces that are a little bigger can be packaged in envelopes or bags and then secured in a padded envelope to protect from further breakage or injury to those handling the evidence. Small particles of glass may be found on the clothing, sole, tops of shoes and cuffs or lower portion of pants of an individual who breaks a window forcefully. In order to prevent dislodging of small glass particles, collect clothing items with small glass particles with caution and do not shake or handle the clothing more than necessary. If the clothing is stained with biological material, allow the clothing to air dry on a clean, dry surface and package in a paper bag. Package unsustained clothing in a plastic bag carefully, sealing all possible openings. The suspect's hair can be combed over white paper to recover any glass particles that may be present. Fold the paper so that it prevents loss of the glass particles and package in a proper envelope or bag. Coming to collection and packaging of glass standards. A comparison of evidence glass to a possible source requires the submission of glass standards. If possible, submit the entire item in packaging that reduces the chance for further breakage. Large windows may require sampling of glass from several different spots, as there may be variation of physical properties even within a single glass pane. Vehicle windshields and some structural glass may be double paned, meaning that two different panes of the glass are present. Standards must be collected from different areas on both glass panes. Package the standards from each pane separately. For window glass standards, collect the glass that is still adhering to the window frame when possible. Collecting glass standards from the ground increases the likelihood of introducing contaminant glass into the standard. Standards for comparison. Windows. Now, send the whole window if the broken window is small or all glass remaining to the laboratory. If the window is large, recover several samples from different areas of the window. If the evidence glass is large enough for physically matching the broken edges or for comparing the fracture lines, hackle marks, surface abrasions or contamination, the whole broken window is necessary. Auto glass. Now, auto headlights. All glass remaining in the shell should be recovered. If it is suspected that new glass has been installed, this should be removed and a careful examination should be made for small chips remaining in the shell from the previous lens which is broken. In such cases, also submit the new lens to the laboratory. Coming to the importance of glass in various cases. Glass is nothing but an amorphous, that is non-crystalline solid material which is often transparent. Glass has an extensive practical, technological and decorative usage in things like tableware, window panes, etc. Traces of glass can often become a source of forensic evidence. Windows are frequently broken in burglaries, headlights in hit and run cases, and bottles or other objects may break or leave fragments on personal belongings of suspects involved in various types of crimes. Glass is encountered as evidence in various forms such as vehicle windows, architectural windows, containers, headlamps and mirror glass. The examiners compare samples of glass found on suspects or found at the scene of a crime with the suspected source of known origin. The physical and optical properties of color, thickness, density and refractive index are measured. Glass examinations may reveal whether questioned or controlled sample belongs to same source or not. The type of glass can also be found out, whether tempered glass, container glass, etc. The direction of force used to break a window, whether from inside or outside. The order of shots fired into a window or windshield. Now, let us come to the conclusion. Glass is an amorphous, hard, brittle substance which is usually transparent, but translucent and also opaque at times. It is formed by the fusion of one or more oxides like silica, boric oxide, phosphoric oxide and some metallic oxides, followed by rapid cooling of the fused material to prevent crystallization of the components involved. Its chemical composition and other properties holds importance in the field of forensic science. With all these information here, we come to the end of today's lecture. Do keep in mind what we discussed today. I will be back with one more lecture in this series. If you want to learn more and enhance your knowledge, you may log on to our website www.cec.nic.in for MCQs, quizzes, LORs, etc. Thank you for your time today. I'll see you in the next lecture. Have a great day.